So this question is coming from May June 20, paper 3, variant 3, and this is the sixth question of the paper. In the first part, we are supposed to sketch the suitable pair of graphs to show that the equation this and this has exactly one real root. So it means that I have to plot the equation on the left and the equation on the right on the same axis and show that they intersect at one point. Sometimes you may have to shift some part of the equation to the other side so that you can draw that graphs. But in this case, x power of 5 and 2 plus x are both easy graphs. We can sketch it very easily without shifting your any of the part of the equation on the other sides. But I always recommend that you first complete your part B and C and then come to part A. What is the reason behind that? Let's say if we are sketching this graph because you are not drawing up to the correct scale, it's not to the scale graphs basically. So what's going to happen over here? I know that x power of 5 graph is going to look like this, 2 plus x graph is going to look something like this. Now this intersecting point we don't know. So let's say if we are writing 1, 2, 3, 4 like this, and this value, after doing part C, you see that the answer is going to be 1.1. So clearly this graph is somewhere like 1.6, 1.7, not near 1.1. So this should approximately look very closer to the answer that you've got in part C. So to make your graphs a bit better, I always recommend that you sketch your graphs at the end once you are done with the other parts of the question. So what I'll do is I'll start with part B and C, and at the end I'll solve part A. So in my B part, I'm supposed to show that if a sequence of values given by the iterative formula converges, then it converges to the root of this equation. Basically, if I can convert this equation and make it in the form of this equation, and then if this equation converges, if the value of x using this iterative formula converges, I can prove that that root is for this equation only because I have rearranged this equation into this form. It's one and the same equation. So for that, either you can go from this step to this step, or maybe from this step to this step. Whichever is comfortable to you, you can do that. I'll go from this step to this step over here. So if I multiply my this over here, or let me just start by writing the formula as it is by removing the subscripts. So x is equal to 4x to the power of 5 plus 2 divided by 5x to the power of 4 minus 1. Now I have to rearrange this into this format. So I'll multiply this over here. So that becomes 5x to the power of 5 and then minus x is equal to 4x to the power of 5 plus 2. Now 2 has to be on the right. I have to shift this x over there and shift this to the left side. So 5x to the power of 5 minus this will become x to the power of 5 is equals to 2 plus x. This is the same equation as we wanted. So it means that if we are solving this equation and getting an answer, it is the root for this equation as well. So because of course the equations are same, that is what I'm trying to say over here. So we are done with the part B, we can go to part C now. So here we are asked to use this iterative formula with the initial value of x1 equal to 1.5 to calculate the root of this equation correct to 3 decimal place, giving the result of each iteration correct to 5 decimal places. So I always recommend for students to show at least 1 or 2 iterations completely, and then you can just write your answers from the calculator directly. What I'm trying to say over here is, you know that x1 is equals to 1.5. Now your x2 will be equal to 4 times x1, right? If you're writing n over here as 1, it will become x2, and then this will become x1 and x1. So 4x1 to the power of 5 plus 2 divided by 5x1 to the power of 4 minus 1 is equal to, put the value of 1.5 over here. Wait, yeah, 1.5 to the power of 5 plus 2 divided by 5 times 1.5 to the power of 4 minus 1. And then just use your calculator to write your answer over here. And the easier way to do this is just write the starting value and press equal to, and then just click on AC. After that, write the entire equation over here into the calculator. In place of x1, simply write answer. Answer is this. So it will become 4 answer to the power of 5 plus 2, and then 5 answer to the power of 4 minus 1. Now what will happen the moment I press equal to sign? This is the answer for x2, that is 1.33, whatever is the number. Now answer itself stores this value now. So if you keep on pressing equal to, now you will get x3. Then again if you press equal to, you will get x4, so on and so forth. So the value I have to write correct to the 5 decimal places as mentioned in the question. So 1, 2, 3, 4, 5. Because of this 9, this one will become 2. So I got my x2 as 1.33162. Now if you want, you can show one more iteration, or you can directly go ahead. By using equal to sign, you can keep on getting new values. So I got 1.273516, 1, 2, 3, 4, 5. So 1.27352, 27352. And you keep on doing this until your answer converges according to the given decimal place over here. So according to the 3 decimal places over here, if my numbers keeps on converging at least 2 times, till that I'll keep on writing my answers and then I'll stop. So my x3 value will become 1.26712345. So 1.26724, 26724. All these values are correct to the 5 decimal places. This number will keep on changing from question to question, so always make sure to read it properly. Now let me write my x4 value. So it will come out as 1.267. So 267, 1, 2, 3, 4, 5, 26717. So clearly I can see that 267 has been repeated, and just for my own satisfaction, I'll press equal to sign one more time. So yeah, these numbers are not changing. It means that correct to the 3 decimal places, I've got my x. So over here you can conclude x converges to 1.267 correct to 3dp. And because you are supposed to find the root correct to 3dp, you can say that therefore x is equals to 1.267 and in the bracket 3dp. And you are done with the C part as well. Now we know that the intersection is happening somewhere in between 1 and 2, but more close towards the half of 1 as compared to over here. So now keeping this in mind, you can draw your graphs quite comfortably. So if I have to sketch my graphs, I'll come over here. And just in case, let's say if you're not aware about how to sketch x to the power of 5, you should be aware about that if you're having x to the power of even number as your equation, it will look like this. It will look like this in terms of shape. Okay, more the even powers, the graphs are going to come closer and closer to your y-axis. And same happens for the odd also. The more the power, the graph shifts closer towards the y-axis. But let's say that x to the power of even generally is in this shape. If I talk about x to the power of odd, except the value 1, because of course 1 is a straight line. So let's say x power of 3 also looks like this, x power of 5 also looks like this. It keeps on coming closer and closer to the y-axis. So with respect to this, I know that x power of 5, 5 being the odd number, is going to look like this. So I hope that this has given you an idea on how to sketch x power of 5. And if I come over here, I can just write 1, 2, 3, minus 1, minus 2, 1, 2, 3. This is my y-axis, this is my x-axis, this is my minus 1, minus 2, minus 3, this is my z. Now for the straight line, y is equals to 2 plus x. I know that the y-intercept is 2 and the x-intercept will become minus 2. So I have to connect these two points. So if I take a straight line and draw over here, it's going to look something like this. I can just extend my y-axis a bit because my intersection is going to happen somewhere over here. And my y-axis is not allowing me to do that. So let me just extend my y-axis very quickly. So it's going to be like this. This is my y-axis. Let me call this 4. And now let me draw the graph. So yeah, of course you can't go beyond your axis. So to show that the graph keeps on continuing, we can show an arrow like this. And this is my y is equals to 2 plus x. Now what about x power of 5 graph? For x power of 5, you can put minus 1. Minus 1 to the power of 5 is minus 1. And for 1 also it will be 1. Similarly, if you do for 2 to the power of 5, it will be 32. Minus 2 to the power of 5 will be minus 32. So at x equal to 2, your graph will be quite high as compared to what you can see in the y-axis. So no problem, but I know that I can draw at least this much, that my graph is coming like this. Your graph should look continuous. And you know the intersection has to happen somewhere over here. So keep on going, and yeah, that is how you can make it look like. And you're done. You can show that because the question was asking us to show that there is one root over here. So that is one real root. You can mark it like this. And if you want, you can also conclude one intersecting point, one intersecting point shows x power of 5 and 2 plus x intersects only once, or has only one real root. And of course, now we know that the root is 1.267, an approximate value with respect to 3 decimal places. So that is how you can do this kind of questions.